Right, so this handler is returning a JSON payload that has like an ID, a URL, and the original payload, I guess, for some reason. I guess that's fine. I guess what we want is the ID. Ah. Okay. Well, I'll have a look at that after the stream. Okay, so I think what we should get here in response body is an ID. How do I want to do this? So in the README, this is way out of date now. All the URLs are wrong. I don't know how some of the description here is accurate, but I think the idea was that this top level endpoint here for the transcription API, would return an accepted response, and it would have a location header. And I think originally the idea I had was that each individual API would have a status endpoint, and that would really all we would do here was we would call the task API. I don't think I want to do that. So I'm going to make this documentation even more wrong. But I think I do want to have I want to send back a header. So how do I do that? Let's see. I think if we look at can we look at the definition of into response? No. If we look at the definition of into response, we should be able to find one where it's taking a tuple with the headers and the status. Maybe. Or I could probably just look at one of the other API endpoints that I had. Okay, impl into response for status code R, where R is into response. Huh. So I think maybe it's the interaction of these two things that makes it work. So we want a header map. I think what I'm going to do is I'm going to look at one of the existing API implementations that is returning headers. Pretty sure the CRUD API does that. Let's see. I think GetLista is because it has to do stuff with pagination. Aha. Okay. So, see if we can do something like this. And we're going to do a header of... Oh, we don't need content type for this because we're not going to have any content. We're going to have a header of location. Now, it's not quite right. What we want is we want the base from, this one. Task API URL / task. Now, what I should really do, probably, is use URL manipulation crate or something to combine these things together. Or I should have the task API return the URL to itself, right? Instead of returning an ID. That would, or in addition to having ID, also return like a self URL for the record. That could be a thing I could do. Instead, I think I'm going to do probably an inadvisable thing. So, because now I have to know, now I have to like construct URLs for this other service, and it's not great, but I think it'll work. Task API, or rather, what are we in right now? Transcription API. Okay, it doesn't have a slash at the end. That's what I was looking for. And then, of course, we don't want the response body as text. We want the JSON. I am surprised. Oh yeah, JSON T. Right. Okay. Do we have a we don't. Okay. I'll make something up here. We need a strut to define kind of the shape of the JSON coming back here. Just call it task. I mean, pretty sure it should be deserialized. What? There we go. And it has an ID. It has other things, but we don't care about those other things. There we go. Oh, Foxy Blue. How are you?
Foxy Blue just cheered 5 bits.
Oh, I didn't read out the emotes? It's supposed to... I'll have to check on that. Thank you for the 5 bits. When was the last time I saw you? You were on Marxie's stream a couple days ago, weren't you? But it's been a while. Feels like it's been a while anyway. Hold on, let me check the alert settings really quick. I thought I had TTS. I was giving Marxie a hard time about not having text-to-speech on his cheering. Text and speech. Say alert text, say cheer message. Yeah, it's supposed to. Maybe it just doesn't like to read the emotes. That might make sense. It's been a bit for sure. I was so looking forward to your Baldur's Gate stream that I got really excited and bought Baldur's Gate myself and started playing it. All right, so we have a task, and we are going to. All right, I think we were waiting. We were waiting to see what the response body is, but that's fine. We'll just you know, take this and do this number, and is that acceptable? Rust Analyzer's not complaining. So we'll run this, and maybe this will even work. Wouldn't that be great? You haven't been around. Yep. I know so little about TikTok. I actually have an account, but I've done nothing with it. A close friend of mine would give me such a hard time if I did anything on TikTok. Hey, Jake Jardashian. Welcome, welcome. I think you were hanging out over on Marxie's stream the other day. I think that's where I saw you from. Cool to see you over here. Just doing some coding. Foxy says, lurking while I try to get my audio stuff figured out. Super excited to stream Baldur's Gate. Yeah. I gotta decide at some point if I'm either going to, Oh, right. So here's the problem. I would like to either do like a face cam for these coding streams, or do like, I could do like an animated thing. I could do that, or something. But the problem I have is that right now I don't know, like, the chat is pretty out of the way. It's see-through. But even that, it would be nice to be able to like capture the like the screen capture, just raw without any of the overlay stuff on it. But it doesn't seem possible to do that in OBS. Like what I would need is I'd like need 2 OBSs. One to capture like the video and then feed that into like a virtual cam into another OBS, or like have a like a dedicated streaming PC or something. Which seems either way is a hassle. The other thing is like with the webcam is that, I mean, I have it. I do it for my other streams, but especially at the beginning of these, I don't want to be on camera at 8:30 in the morning. You're gonna be lurking for a while. I got some stuff to do before you lock in for the day. Okay. Appreciate the lurk. Appreciate all the people coming out and watching. Okay, so that seemed a lot faster than normal. But anyway, maybe if we call this API now, this API. So this is our top level kind of meta detection. Let's do something else here. Let's give it multiple files to process. So let's have some fun here, and let's process the ones from today, right? So there we go. Control A, Control C. So I'll paste that in there. Come on. There we go. All right, and let's see. 08, 47, 41. 47, 41. I don't know why sometimes it's like a little extra. It's not exactly 20 minutes. It's down to whatever OBS wants to do, right? OBS is just going to do whatever it wants to do. But this one is actually exactly 20 minutes, so there we go. 9:07. And ultimately, like, we're gonna have the UI do this somehow to like take all the files and run it. It's gonna be interesting. I think I do like the idea of having the transcript be per stream. That's gonna give us kind of like, at the end of the day, the data is the data. It's just about how I'm thinking about how the things relate together. More than anything else, it doesn't really matter where and which table things are stored in. Like, at least until it does matter. But I don't think we're anywhere near the point where we're going to be worried about, you know, optimizing at that level. Let's see. So 07 to 27. See, now they line up. And this one is not finished yet, so we'll not touch that. So the stream so far. So we'll send this off. And invalid type. Integer 4. Expected a string. It's not good. I think it did trigger the work, though. I think what happened here was this. Here, when we're parsing the JSON, we expected a string. But ID was a number. Why is ID a number? ID is a number because it's a number. It's a number. Okay. I don't want it to be a number, though. So can we just do that? I guess so. So in the meantime, though, let's we go back to Docker. And we look at the task worker. Hey, look, stuff happened. Got task key, task 4. So this is the task that just got queued up. Got task data, ID 4. See, it's a string here. Anyway. And here's the payload that we sent off to it with the list of files. So what should be happening is if we go back and look at the task worker. Wait, this is the task worker. Okay, so it's right. So how does this work? Yeah, transcription API. So now it's going to take the first file from today, and it's going to this is output from FFmpeg, extracting the audio and converting it into a format that hopefully Whisper likes, which it seems to. So here we go. Here's the beginning of today's stream. Interesting. Here's the beginning of today's stream. We were already on the second file. Hey, good morning, Brainless. How's it going? Were the first words I said. It could slot the castle? What? I don't think I said that. Yeah, I was like, wait, I'm here since early. Yeah. No. We're looking at what happened at the beginning of the stream. Exactly. Still configuring the new OS, adding your .dot files, additional software. Yeah. As you do. Let's see. We want to have we have a detect a segment API endpoint that does a single file. Then we have the goal here is to collect, and then the goal here is going to be to have this detect endpoint that is going to dispatch out. Yeah, lots of ums. Oh, here we go. All right. Yes. Let me pull up Redis Insight. See, this is the worst part with video editing and all this kind of looking back at things that you said already. Is things like that really stand out? All the ums, all the pauses, all of the all of that. Okay. Task for data. All right, so we are accumulating data, which is good. Still processing. So yeah, this will be a minute, but I think this is pretty good. So with the change that we just made, we shouldn't get that error anymore, which means we should get the right URL to be able to talk to the task API. Although we're probably going to have to change that, actually, now that I'm thinking about it. So in here, we are taking this task API URL, and we're using that to construct a new URL. The problem is that URL only makes sense within like this service talking to the other service. When it comes to like a URL that the front end could call, it's wrong. Like, because it's going to refer to like task API, which is that like internal Docker name, and that's not a host name that like outside of Docker, like in my web browser, it can use. So probably a thing we could do is have a external URL that we have as well. And we'll add that to the state. And then we have to just go all the way up. So we need to add that to how we're constructing the app state. Fortunately, this is something that Copilot is good at doing, is just kind of like copy, paste, fill in blank kind of work. There we go. And then I'll save that. And then we just need to go, and then we just need to, you know, finish the rest of the YAL. No, it's not that bad. Add this environment variable. But it's not tasks. It is like API records. ORTS. Tasks. With no ending slash, because the code is going to add a slash and then the ID to it. I think that's right. Right, because our proxy is on 8080. And yeah, we could like have this all configurable as well, and maybe I'll go back and do that at some point. But unless I'm willing to do everything right now, I would rather just hard code it so it's easier to find all the places. Okay. So yeah, I think that's good. I think maybe we're close to being able to look at this, like look at actually doing stuff in the UI. Wouldn't that be nice? And so in my original plan, an hour and a half ago, so we said recap changes. Okay, so we did that. It's done. Just put X. How about X? Okay. Finish API that dispatches task API. I think we've basically done that. I don't think I'm going to do the silence detection API right now. It's basically the same thing. I might honestly do it between streams depending on time, but it's going to be basically the same thing. In fact, at some point probably, given the nature of this, like this, a lot of this code can probably just be like abstracted into a shared function that's used by, like you can put it into the common API lib. Step 3 is step through the workflow in the UI and figure out what needs to be done. We started doing that, right? We started looking at the React admin UI. Are we still waiting for stuff to get built? That's not the right key. Here we go. Okay, so that's built. So let's see. Did this work? Yeah. Okay, so we have our 4 records in our task data. So here are all the transcript segments from all of our videos. right? So, hey, good morning, Brainless. How's it going? Yada, yada, yada. To our task API. Task API is going to then in turn call back to, so, here we go. And then the most recent thing. At the end of this 20-minute segment, I said, well, we'll just, That's great. All right. So, right. So we're going to try one last time. I think what I'll do is, it's fine. I'll just run the same request again. No, that was supposed to work. Expecting a string. Okay. I thought I fixed that. Okay, let's look in Docker. Do we have any logging here in transcription API? Yeah, internal server error. Request. Task API response. So we get a response. It has URL. That's the response. And we don't have the body. I think we didn't log the body, or we logged the body after parsing it. Is that right? I know we got rid of logging the response body when we switched to JSON. So the issue here is the task says that the ID is supposed to be a string. And then in task API, we're supposed to be returning a string, yet it's not. This is the right place, right? Create handler? Yeah. And is there like a different case where... I mean, obviously the ID is an integer here. That's how we're representing it in Redis land. But this is the only place where we're returning the response, and the ID is a string. So what's up with that? When was the last time the task API was restarted? Task API last started 1 day ago. Okay. I'm not sure why the Docker Compose up didn't restart all the things, but I guess that's why. Okay, so what I'm going to do is I'm going to restart this guy. There we go. Listening. Yay. All right, so go back to Postman, and yeah, I'll just run the whole thing again. It's fine. No, it's still not working. What am I unsure about? Well, many things. So this error, I'm pretty sure. Let me take you through it. Right. So in transcription API, in here, we're calling the task API, and I'm pretty sure the error that we're getting is because the task API is returning an integer for ID, and so when we're trying to parse the JSON, we throw an error because we say the task should be a string, and it should be now because I thought I fixed it. Oh, wait. So the question is, why is the task API doing things that it shouldn't be doing now that we've changed it to return a string? Right, ID is now a string. So, and I think I know the answer. Right, I think I know what I need to check next, which is the task API. What image is it using? And when was that image built? So here's the image. Is there a way to see? Image. Ba, 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 ba. So I suspect that maybe our task API is not getting rebuilt. Yeah, see, running started. Is it not building the task API? I'm not sure. Docker. So many images. Try to do Docker compose up -d force recreate name of the task API. Yes. Let me see if I can find. many images. Latest was created 7 days ago. Seems like a problem. Yeah. Okay, let's try what you suggested. DOCKERCOMPO. Typing is a little slow still. It's gonna be slow for a long time. -d -- force GCREAT. I am trying to focus on keeping my fingers on the home row and trying to build the habit of, like, you know, being able to you know, what am I trying to say? Trying to focus on doing the things that I need to do in order to be able to, like, build the muscle memory for this keyboard layout. Name of the task API. What is the name of the task API in actuality? Is it just task_API? Let's try that. I realized after many years of typing, I use 2 fingers in each hand. Ah. Yeah. Well, currently, I tried a word per minute test the other day, like 2 or 3 days ago, and I think it was at like 16. So I have a ways to go. Right now, it's not about the number of fingers. It's about not knowing where the keys are. I feel like that didn't do anything, though. Okay, Docker. Isn't this a command? Task _API. I need to find a different way of hitting the underscore as well. In fact, I have a different way of hitting the underscore. I just need to remember the right layer combo. This is just a restart with check. Last imaging used that. Yeah. Well, the last image apparently is from a week ago. So I think this is the issue, is that for some reason the build was not happening. Yeah. Well, so what I've been doing every time is, like, Docker compose this thing, which does a dash build, but apparently that was not updating the image. So it's curious. I guess that's why it was faster, though. There we go. Okay. So this should at least... I think this should work now. Yeah, so we don't get a response body because there was an error. We get 202 accepted. We get a header, a location header back. The wrong one though. Huh, didn't I... Task API external URL. And then in here... Task API external URL. Okay. Fine, I'll do it the hard way. Does that rebuild everything? I think it should, right? Is Docker compose build? How have I been successfully doing this without running into this problem? Ooh, I did update Docker between last stream and this stream. Maybe some behavior changed. It did. I thought it did. Oh, we're waiting for this. Who else in the chat? All right, all right. So if you're looking at all this and you're like, what's going on? How did we get here? I do put all of the VODs because the VODs only stay here on Twitch for, you know, some amount of time. So I do take these streams. It might be clear because I was talking earlier about the fact that I'm building this tool to kind of automate this stuff. But I have a YouTube channel, and it's over there. I've just linked it. That has like all the past. There's actually a playlist for Glowing Telegram that kind of is all the streams. This is, I guess, the 12th stream working on this project. So there's that, if you find that helpful. Okay, so yeah, I think what the command was doing was just like, you know, -d -- build, or yeah, that. But let's try it again. So I was doing Control-Shift-P, Docker Compose up. Yeah, Docker Compose -f up -d -- build. I'm pretty sure that's what I've been doing every time. Although, I think I did note earlier today that it was faster than it was before. Like, I think the previous streams, it took, you know, minutes to do. So, that's interesting. All right, so one more test here. There we go. So now we have localhost 8080 API records tasks 8. Now, this URL doesn't actually work right now because we've not implemented the other endpoints for the task API to do things. Like if we go to this, it's like a 404, right? No, we just return empty JSON. I mean, we have the endpoints. We just don't have them doing anything. Okay. Makes sense. Okay, so how do we get from having this and having this new API to actually being able to like have all of the stuff from Redis in Postgres? Like all this stuff is stored in Postgres. Our segments of the transcripts are stored in Redis. Now, do we need to get the data from Redis and put it into Postgres? I think probably yes. I want to imagine that eventually we want to clean up the task data from Redis. That while we have persistence, it's not our primary data store. I mean, we could just like leave it there forever, but I don't think I want to. What are the pros and cons? Right? So what are the pros and cons of like, we could just leave it in Redis. We have a list, task 4 data, right? We could just have this data here. I think it's kind of interesting. Then maybe in that case, what we do is if we did that, what we would probably do is in the record for the stream, I would just have some kind of column that will be like, here is where you find the transcript task data, right? And then it would have to call another API, like call into the task API using that URL that we just tried to go to that's returning empty body right now. And it would give this. That's an option. Just kind of thinking right now. So now that does mean now we have data in 2 places and kind of in the long term, right? And that, you know, in practice might be okay. I mean, it's not like we want, if we want things to be reliable, we got to care about Redis anyway and keep it running and stuff. But it is kind of nice to be like, okay, well, Redis is just where we're temporarily storing data. You know, there are considerations there if we were doing this for a serious application, shall we say. On the other hand, I think I was kind of envisioning that what we would do here is that, so if we, let's kind of analogize here, right? So when, and I showed this earlier in the stream, right? So we can put in a prefix for a stream. Let's do another one. Let's do another one here. So like if I go to my thing over here in Twitch, and I grab another stream that I've not already ingested here. So the one from, let's see, what is this? 2023, 12/31. I think that was. Yes. There we go. I save this. All right, and so this is the stream from the last day of the year. I have this button, scan for clips. And so what this does is this goes off and calls an API. And that API pulls a bunch of metadata from disk, right? What it doesn't do is it doesn't talk to Postgres or any other database. It just returns stuff to the front end. The front end then works inside of React admin to like load the data. So this is not saved yet, right? So if I were to just to refresh this record, all that's gone. It's not loading or anything. It wasn't saved, right? So we make the UI responsible for taking the data from the API, presenting it to the user to like review and confirm, and we're leveraging how React admin works. This library / framework that we're using for this UI for that purpose, and so that we can just save it. So we could do the same thing with the transcript, right? Where we are, maybe we'll add tabs to the stream record, right? So maybe we take the video clip stuff and we put it on a separate tab, and then we have another tab for the transcripts. like the segments of that, and we'll have a UI for that. And then so we'll just have a button on that tab that's like transcribe video. Now, the problem with that is how it works. Scan for clips doesn't take that long, and it's just one API call that pulls in all the information. That's why it's one API call, is because it doesn't take too long just to gather this information. Whereas transcribing the video takes, it's like 1.5 minutes per 20-minute segment. There's 2046. There's like probably 9 or more segments. So we're talking about maybe like 15 minutes to do all the work. So we can't just it defeats the purpose to have something where we're like, okay, the user goes to a tab, they click the button, and then you have to wait 15 minutes for the UI to populate. They can't go anywhere else, or the UI won't populate. It makes no sense. But what we could have is we could have a tab where you click the button, and then you get a thing saying like, okay, your task is in progress. And that gets kind of interesting because how do we want that to work? I think what we would need to do is when you click that button, this imaginary button on this imaginary tab, that, and I could just make it and we could see it, but I don't want to go down that path until I think this through a little bit further. So you go to the tab, you click the button, that makes the call to the transcription API, right? But that just like it adds the background task, right? And it gets back the URL for that. That, I think what we could do is we could have the front end make that call, get the response, make another call to the CRUD API to store that data, and then tell the user, okay, now here's your task. How's that going to work? What's that going to look like? Okay, so let's go back to this. So in our transcription API, we have this location. Okay. Is that good enough? I think maybe, right? So what we could do is the front end is going to call the transcription API. And then it's going to get that URL back, and then it can just like make a request there and get that response back and take that. And then it will have the ID. It will have all the details that it can then use, maybe, to call the CRUD API and save the task information to the record. Now, does it have to be this complicated? Does it have to have this many steps? No. Like we could have we could have like one backend, right? And we could have this API call, like do all the things. Like there's lots of different things we could do. Like we could sacrifice it, the whole task worker thing if we wanted to. Given the fact this is something I'm just running locally, I could just have it can make a backend request. For that matter, we could do other things. We could have like implemented this with other kinds of tooling. That's fine. There's lots of different ways of lots of different possible solutions, right? But this is the one that gives me. This is the one that I liked, and I still like it. And anyway, that aside, I think I have a good sense of what the next steps are going to be, right? So what we're going to do, I think we're going to let's let's make a new list of things here. Right. So we're gonna say 1. We want to we need to implement no. The task get endpoint. Endpoint. Getting better. So that's going to allow us to get the information about the task and then create a CRUD. Make it possible. Let me snooze that ad for a second so I can get through this. Okay. Make it possible to save info about the task to the stream record via the CRUD API. Now, the reason I want to do it like that is that my kind of constraints around how I want the microservices to work is I want them to let me make this a little bit bigger too. I think that's a little small. There we go. Okay. I want the microservices to like talk to one thing. I don't want to have a rat's nest, a kind of interwoven mesh of services calling other services, because it's hard to understand. It's hard to manage without a lot of tooling. Yeah, it's you can do it, and sometimes it may even be necessary to do it. But if I have a choice of how I'm going to structure things, I'm going to make it so that my front end is going to call through a proxy microservice that is maybe either going to talk to other microservices as kind of a coordinating thing, or it's going to talk to a database. It's generally not going to do both. It's kind of the principle that I've been approaching this, right? So if something's talking to Redis, maybe it's using that to like orchestrate things, or it's just talking to Redis because it's a worker, or it's talking to Postgres, or it's talking to other, so limiting the inter-service connections, I think, is an important thing, is what I'm trying to get at. So implement task get endpoint so we can get information about the task. Once we've queued it up, make it possible to save info about the task to the stream record. And then once we've done that, then we could finally get, it's been like a couple of streams, I think, since I've really done anything in the UI. Then add tabs to the stream, stream. I guess it's the edit view. For the video clips and transcript. Segments. With task status. I think that'll be interesting, right? So we're gonna show, okay, the task is underway, the task is done, and then I guess when the task is done, we'll need the user to like click a button, and buttons to start task, and button to get results. right? Because once you click that button to get the results of like, here's the different segments, then you can review it and choose to save the whole record of the stream or not. And that kind of matches kind of the workflow we have with the video clips, but in a world in which we are asynchronously processing to get the transcripts from the video clips. Okay, so that is the plan. I don't know how much of that we're going to get through in the final part of the stream today, but I'm going to take a little break